Hey everyone, and welcome. Today we're going to tackle one of the biggest questions in the world of tech. How exactly do you build an app that can go from just a few users to millions and, not explode? Let's jump right in.
So this is the big one. Seriously. Imagine you build an app, your friends love it, and then overnight it just goes viral. You wake up and suddenly a million people are trying to use it all at once. How do you possibly survive that? Well, that's exactly the journey we're going on today.
All right, to really get a feel for the problem we're trying to solve here, let's look at the two extremes, the starting line and the finish line.
Okay, so when you've got like 10 users, life is easy. Everything can just hum along on a single server with a super basic setup. No problem. But a million users? Whoa, that is a completely different beast. All of a sudden, you're dealing with just insane amounts of traffic, mountains of data, and this really terrifying risk that if one little piece of your system breaks, the entire app goes down for everyone. That's what we call a single point of failure. It's the stuff of nightmares for developers.
So how do you stop that from happening? Well, it's not magic. It's all about smart engineering. You need to build your entire system on a really strong foundation, using principles and tools that are specifically designed to handle that kind of pressure.
So what does this quote-unquote strong foundation actually look like? Well, it all starts with a toolkit of core concepts. Think of these as the pillars that every single developer needs to understand to build systems that won't crumble under pressure. First up, we have scalability. This is basically your system's ability to grow. So when you get that huge surge of users, can you just add more resources, more servers, more power to handle the load without everything just grinding to a halt? If you can, your system is scalable. Next up is reliability. You can think of this as your system's toughness. It's the promise that if one server suddenly goes offline, your app doesn't just die with it. It keeps on working. Maybe it's a little bit slower for a minute, but it stays up and running for your users. Then we've got availability. To put it really simply, is your app online and usable right now? You'll often hear people talk about this in terms of nines. So 99.9% availability, that's 3 nines, and it means your app is only down for about 8 hours over an entire year. 5 nines, 99.999%, means it's only down for about 5 minutes a year. That's the goal. Now, consistency. This one is absolutely crucial. It means that if I update my profile picture while I'm in London, my friend in Tokyo sees that brand new picture immediately, not the old one from 5 minutes ago. Everyone, everywhere sees the same correct data at the exact same time. And finally, let's talk about speed. Think of it like a highway. Latency is how long it takes for one single car to get from the start of the highway to the end. Throughput is how many total cars that highway can handle every hour. Ideally, you want both. Low latency, so a fast trip for that one car, and high throughput, so lots of cars can get through at once. Okay, so we've got our toolkit, right? Scalability, reliability, availability, consistency. It all sounds great, but, and this is a huge but, here's the twist. In the real world, you can't always have everything. In fact, these pillars are often in direct conflict with one another. And this conflict, it's not just some random, casual challenge. It's actually a fundamental mathematical law of system design. It's called the CAP theorem, and it forces developers to make what can honestly feel like an impossible choice. The CAP theorem is really a cornerstone of building any large system. It says you have 3 things you want: consistency, availability, and something called partition tolerance. Partition tolerance just means your system can survive if the network connection between its different servers gets broken. And what the theorem proves is that when that network partition happens, it is mathematically impossible to guarantee both perfect consistency and perfect availability. You have to choose one. So let's look at them again. C for consistency, A for availability, and P for partition tolerance. The rule, the law of the land, is simple. You can only pick 2 of the 3. This single trade-off is at the very heart of almost every major decision in modern system design. This table makes it super clear. Now, since any modern app on the internet has to be tolerant to network partitions, you just can't avoid them, you're really left with a choice between CP and AP. If you pick CP, you're choosing consistency. That means you might have to sacrifice availability for a moment. Maybe the system goes offline for a few seconds to make sure all the data is perfectly in sync. But if you pick AP, you're choosing availability. The app will stay online, but you might sacrifice immediate consistency, meaning someone might see slightly old data for a moment. So you can see how developers are living with these huge trade-offs every single day. So how do they manage it all?
Well, it all comes down to adopting a very specific kind of mindset.
Engineers have this whole toolbox of strategies to help them balance these trade-offs. You've got things like load balancers, which are like traffic cops, spreading out users to improve availability. You've got caching, which keeps frequently used data close by for speed. Database replication creates backup copies of your data for reliability. And CDNs store things like images and videos closer to users all over the world to cut down that latency.
But here's the thing. Using these tools effectively isn't about following some simple recipe. It's a whole way of thinking. First, you have to really deeply understand what the application's main goal is. Then, you identify your real-world constraints. Budget, time, the team you have. Only then can you properly analyze the trade-offs, like consistency versus availability, and finally choose the right combination for your specific problem. And this right here is the absolute key takeaway. The real skill of system design isn't about memorizing a bunch of patterns from a textbook. It's all about the analysis, the balancing act. It's about thinking critically about what you're gaining and what you might be sacrificing with every single decision you make. And that brings us to our final and probably most important point. There is no single best system design out there. A design that is absolutely brilliant for, say, a banking app that needs perfect consistency would probably be a terrible design for a social media feed, which cares way more about being available all the time. The goal is always to find the best choice for the context. So the next time you're scrolling through an app, think about it. What trade-offs did its designers have to make to bring it to you?